Download this code from codegive.com, link in the description below. Don't fail your code. A comprehensive guide to preventing common programming mistakes. Just like a driving test requires careful attention to detail, safe practices, and an understanding of the rules, writing good code demands the same level of diligence. This tutorial aims to equip you with the knowledge and strategies to avoid common programming pitfalls that can lead to code failures, whether it's runtime errors, incorrect output, or just plain unmaintainable code. We'll cover key areas like understanding common error types, identifying the root causes of failures, defensive programming techniques, building robust and reliable code, code style and readability, making your code easier to understand and maintain, testing strategies, catching errors early and often, debugging techniques, finding and fixing errors efficiently, example code snippets, Python demonstrating principles in practice. Let's dive in. Understanding common error types, the root causes of failures. Before we start preventing errors, we need to understand what they are and where they typically come from. Think of this as knowing the common reasons people fail a driving test, like speeding, not checking blind spots, or failing to yield. 1. Syntax errors. These are the easiest to catch because the compiler or interpreter usually finds them for you. They are violations of the language's grammar. Examples. Misspelled keywords, example will instead of while. Missing colons, example in if statements, for loops, function definitions. Unbalanced parentheses or brackets. Incorrect indentation, especially in Python. Prevention. Pay close attention to detail. Use a code editor or IDE that provides syntax highlighting and real-time error checking. Example, Python. 2. Runtime errors. These errors occur while your program is running. They are often caused by unexpected input or conditions that the program wasn't designed to handle. These are harder to catch than syntax errors. Examples. Division by zero. Accessing an element outside the bounds of an array or list, index error. Trying to perform an operation on a variable of the wrong type, type error. Memory errors, example out of memory, accessing freed memory. File not found. Network connection errors. Prevention. Anticipate potential problems and write code to handle them gracefully, using try-except blocks or similar mechanisms. Validate inputs to ensure they are within acceptable ranges and of the correct type. Example, Python. 3. Logic errors. These are the trickiest because the program runs without crashing, but it produces incorrect results. This is like following the rules of the road but accidentally ending up at the wrong destination. Examples. Incorrect formulas or algorithms. Using the wrong comparison operator, example instead of equals. Infinite loops. Incorrectly updating variables within loops. Incorrect assumptions about data. Prevention. Carefully plan your algorithms and logic before you start coding. Use debugging tools to step through your code and observe the values of variables. Write unit tests to verify that individual functions and components are working correctly. Review code carefully, code review. Example, Python. 4. Resource leaks. This type of error occurs when a program doesn't properly release resources it has acquired, such as memory, file handles, or network connections. Over time, this can lead to performance degradation or even system crashes. Asterisk examples asterisk. Asterisk opening a file but not closing it. Asterisk allocating memory but not freeing it, especially in languages like C/C++. Asterisk not releasing database connections. Asterisk prevention asterisk use techniques like RAII, resource acquisition is initialization, and try, finally blocks to ensure that resources are always released, even if exceptions occur. Use context managers, the with statement in Python, for file operations. Asterisk example, Python. 5 concurrency errors, race conditions, deadlocks. These errors arise when multiple threads or processes access shared resources concurrently without proper synchronization. Asterisk examples asterisk. Asterisk 2 threads trying to update the same variable simultaneously. Asterisk 2 threads waiting for each other to release a resource, resulting in a deadlock. Asterisk prevention asterisk use synchronization primitives like locks, semaphores, and condition variables to protect shared resources. Design your code to minimize the need for shared resources. Carefully analyze potential race conditions and deadlocks. Asterisk example, conceptual, synchronization required. To fix this, you would use a lock. 2. Defensive programming techniques, building robust code. Defensive programming is about anticipating potential problems and writing code to handle them gracefully. It's like wearing a seat belt and checking your mirrors. You're not expecting an accident, but you're prepared for one. 1 input validation asterisk always validate inputs to ensure they are within acceptable ranges and of the correct type. This prevents unexpected behavior and crashes. 2 error handling, try, except use try, except blocks to catch exceptions and handle them gracefully. Avoid catching generic exceptions, except exception, unless you have a very specific reason to do so. Catch specific exceptions to handle different error scenarios appropriately. 3 assertions asterisk use assertions to check assumptions about your code. Assertions are statements that should always be true. If an assertion fails, it indicates a bug in your code. Assertions are typically disabled in production environments. 4 logging asterisk log important events and errors in your program. This can be invaluable for debugging and monitoring the health of your application. 5 resource management, RAII, context managers ensure that resources are properly released when they are no longer needed. Use RAII, resource acquisition is initialization, principles in languages like C++ and context managers, the with statement, in Python. 6 limit the scope of variables asterisk declare variables as close as possible to where they are used, and keep their scope as narrow as possible. This reduces the chances of accidental modification and makes your code easier to understand. 7 fail fast asterisk if a program encounters an error condition that it cannot reasonably recover from, it's often better to crash immediately, fail fast, rather than trying to limp along and potentially corrupt data. This makes it easier to identify and fix the root cause of the problem. While this may seem counterintuitive, failing quickly avoids the issue of a program running in a corrupted state and producing unpredictable or misleading results later. Use logging before crashing to capture context for debugging. 3. Code style and readability, making your code easier to understand and maintain. Readable code is easier to debug and maintain. Adhering to a consistent code style also makes it easier for teams to collaborate. This is like following the rules of the road so everyone understands your intentions and can anticipate your actions. 1 Follow a style guide asterisk choose a coding style guide, example PEP 8 for Python, Google C++ style guide, and stick to it. Style guides cover aspects like indentation, naming conventions, line length, and comments. 2 meaningful names * use descriptive and meaningful names for variables, functions, and classes. Avoid single-letter variable names, except for loop counters in simple cases. 3 comments * write comments to explain complex logic, non-obvious code, and the purpose of functions and classes. Don't just comment on what the code does, explain why it does it. Keep comments up to date as you modify the code. 4 Keep functions short and focused * functions should do one thing well. If a function becomes too long or complex, break it down into smaller, more manageable functions. This is an application of the single responsibility principle. 5 Avoid code duplication, dry. Don't repeat yourself. If you find yourself writing the same code in multiple places, refactor it into a reusable function or class. Duplicated code is harder to maintain and increases the risk of errors. 6 Consistent indentation * use consistent indentation to make your code easier to read. Most editors and IDEs can automatically handle indentation. 7 Blank lines * use blank lines to separate logical blocks of code and improve readability. 4. Testing strategies, catching errors early and often. Testing is crucial for ensuring that your code works correctly. The earlier you find errors, the easier and cheaper they are to fix. This is like regularly checking your car's fluids and tire pressure to prevent major problems down the road. 1 Unit testing * write unit tests to verify that individual functions and classes are working correctly. Unit tests should be small, focused, and independent of each other. Use a unit testing framework, example Unitest or ptest in Python. 2 Integration testing * test how different components of your system work together. Integration tests are more complex than unit tests and may involve multiple functions, classes, or even external systems. 3 System testing * test the entire system as a whole, from end to end. System tests simulate real-world usage scenarios and verify that the system meets its requirements. 4 Regression testing * after fixing a bug, write a regression test to ensure that the bug doesn't reappear in the future. Regression tests are also used to ensure that new changes don't break existing functionality. 5 Test-driven development, TDD write tests before you write the code. This forces you to think about the requirements and design of your code before you start coding. TDD follows the red-green refactor cycle. *Red * write a failing test. *Green * write the minimal amount of code to pass the test. *Refactor * improve the code while ensuring the test still passes. 6 Code coverage * use code coverage tools to measure how much of your code is covered by tests. Aim for high code coverage, but don't treat it as the only metric. Well-designed tests are more important than code coverage alone. 7 Continuous integration, CI set up a CI system, example Jenkins, GitLab CI, GitHub Actions, to automatically run your tests whenever you commit code. This helps you catch errors early and often. Debugging techniques, finding and fixing errors efficiently. Debugging is the process of finding and fixing errors in your code. It's like diagnosing a problem with your car and then repairing it. 1 Use a debugger * learn how to use a debugger, example PDB in Python, GDB in C/C++. A debugger allows you to step through your code line by line, inspect the values of variables, and set breakpoints. When the code reaches pdb.set_trace, the debugger will start, and you can use commands like n, next line, p, print variable, c, continue execution, q, quit debugger, to examine the state of your program. 2 Print statements * use print statements to output the values of variables and trace the execution flow of your code. While debuggers are more powerful, Print statements can be a quick and easy way to get information about your program's state. Remember to remove or comment out your debug print statements before deploying your code. 3. Read error messages carefully. Error messages often provide valuable clues about the cause of the error. Pay attention to the line number, the type of error, and any additional information provided in the message. 4. Simplify the problem. If you're dealing with a complex bug, try to simplify the problem by isolating the code that's causing the error. Comment out sections of code or create a smaller test case that reproduces the bug. 5. Rubber duck debugging. Explain your code to someone, or even an inanimate object like a rubber duck. The act of explaining your code can often help you identify errors. The key is to articulate your code's purpose and how it's supposed to work. 6. Divide and conquer. If you're debugging a large function, divide it into smaller sections and test each section individually. This can help you narrow down the location of the error. 7. Use version control. Use a version control system, example Git, to track your changes and revert to previous versions if necessary. This allows you to undo mistakes and experiment with different solutions without fear of breaking your code. 8. Learn from your mistakes. When you find a bug, take the time to understand why it happened and how you could have prevented it. This will help you avoid making the same mistake in the future. 6. Example code snippets, Python demonstrating principles in practice. Let's put these principles into practice with some more detailed examples. 1. Safe input handling and validation ***. 2. Defensive function with error handling and logging ***. 3. Example of unit testing a file processing function ***. Conclusion. Avoiding coding errors is a continuous learning process. By understanding common error types, adopting defensive programming techniques, writing readable code, implementing thorough testing strategies, and mastering debugging skills, you can significantly improve the quality and reliability of your software. Remember, writing good code is not just about making it work, it's about making it work reliably, maintainably, and efficiently. Just like safe driving, consistent practice and attention to detail are key to success. Good luck.